Today's experiment is called To Fly or Not to Fly, the effect of different lengths of parachute cords. Just as a brief introduction, my name is Megan and I go to ASU Barrett Honors College. I'm majoring in biomedical sciences and I have a minor in global health. I'm currently in my third year, and a fun fact about myself is that I'm part of the ASU Women's Club lacrosse team. In the sport of skydiving, a person jumps out of an airplane from a high altitude, flies through the air, and releases a parachute to help them fall safely to the ground. As a skydiver is falling, the force of gravity is pulling the skydiver and their parachute towards the earth. The force of gravity can make an object fall very fast. The parachute slows the skydiver down because it causes air resistance, also known as drag force. The air pushes the parachute back up and creates a force opposite to the force of gravity, slowing the skydiver down. As the skydiver falls slowly to the earth, these push-to-pull forces are nearly in balance. In this science experiment, you will test whether the length of a parachute is important for slowing down the speed of the fall. You will make a series of parachutes from small to large lengths and test how quickly they fall from the same height. In this experiment, the length of time will be about 1 to 1.5 hours. The age group will be for middle schoolers, and the topic we're going to be discussing is physics, with the subtopic in air resistance. Some key concepts to know about are gravity, air resistance, drag force, and load, which you will all see in this experiment. The abstract for this experiment will be, how do parachutes work? Do longer or shorter parachutes take more time to hit the ground? In addition, the lesson objective is to test different length parachutes to see how changes in the size of the parachute affect the time of flight to the ground. Materials will be for a group of 4. A group will need 4 grocery bags, 4 rulers, 4 scissors, lightweight string, about 16 feet, 4 stopwatches, 4 pennies as the mass, tape, and a tall place to drop the parachutes. This place should be about 2 meters above the ground, such as a table or a countertop. Each parachute will be made out of a grocery bag material, so first cut open the bags to make a flat sheet of plastic. You will make a series of 4 parachutes of the same size. For each parachute, tie a knot in each of its 4 corners. The knots will be used to anchor your string. Cut 16 pieces of string, 4 of each, 15 centimeters, 20 centimeters, 25 centimeters, and 30 centimeters. Each parachute will need 4 pieces of string. For each parachute, tie one end of each piece of string around one of the 4 knots. Attach 1 coin to a piece of tape, and then attach the strings onto the sticky side of the tape. Bring a stopwatch and the parachutes to a safe high surface for your test, about 2 meters from the ground. Using your stopwatch, time how long it takes in seconds for each parachute to fall to the ground. Be sure to release the parachute from the same height each time. You may want to have a helper help the parachutes when you release them. Test the parachute 3 times. Each time, record your results in the data table in your lab notebook, and then make an average of your data. Since you will be testing each parachute 3 times, it is important to cover the foundation of how to calculate the average. The average will be calculated by adding all of the times it took for the parachute to reach the ground and divide it by 3. Once you do that, you'll get the average time to land for that parachute. Since we're on the topic of parachutes, we have to focus on the idea of force. So in the diagram above, you can see that normal force acts up while gravitational force acts down. And in some certain cases, you have force applied and force of friction to the sides. In the parachute example, there is an abundant amount of normal force acting on the parachute as it's falling down. There are quite a bit of variations that can go along with this experiment. For example, load, which would be a change in the number of masses to change the weight of the load. Another example would be height, so you would drop the parachute from different heights. Another one is size. You would change the size of the parachute. In addition, there's string weight. You can change the type of string. Additionally, there's materials. You can change the type of parachute material. For example, you can use tissue paper, magazine paper, newspaper. And lastly, there's also shape. You can make sure parachutes a different shape, such as a square, a circle, a diamond, whatever you like. At the end of your experiment, make sure that you compare your data to the rest of your group mates. In addition, you should share your data with the rest of the class and see if they got similar data.